In this investigation, we will look at ideas of evaluating and solving while using functions represented in a variety of ways. To introduce these ideas, let's look at the following context. So suppose a 15-inch candle is lit and burns at a constant rate of 1.5 inches per hour. And I have this shown here. Now, if t hours have elapsed since the candle was lit, then the expression 1.5t represents the number of inches that have burned from the candle, and therefore the expression 15 minus 1.5t represents the remaining length of the candle in inches. So if we let L represent the remaining length of the candle in inches, then we can write the formula L equals 15 minus 1.5t to express L in terms of t. Now, given any number of hours since the candle was lit, we can determine exactly one value for the remaining length, and therefore L is actually a function of t. We can call this function f, and we can write a function formula for f. So f of t, which represents the remaining length in inches, is equal to 15 minus 1.5t. That's because f of t and L are representing the value of the same quantity. Now, let's suppose we want to know how long the candle is 4 hours after it was lit. We know that the expression f of 4 represents the remaining length of the candle 4 hours after it was lit. And we know a formula for f of t. Recall that f of t is equal to 15 minus 1.5t. So f of 4 is equal to 15 minus 1.5 times 4. And this value is equal to 9. So this tells us that 4 hours after the candle was lit, the remaining length of the candle is 9 inches. We call this process of determining an output value given an input value, evaluating the function. So this whole process right here, we might refer to as evaluating. Determining an output value given an input value. Now let's suppose that the candle is 12 inches long, and we want to know how many hours have elapsed since it was lit. If the candle is 12 inches long, then we can write the equality f of t equals 12. Now, since f of t was equal to 15 minus 1.5t, and we know that the value of this is 12, we can write the equality 12 is equal to 15 minus 1.5 times t. All I'm doing here is looking at these values and setting these two expressions equal to each other. Now, if we solve this equation, we'll see that 1.5t is equal to 3, and so t is equal to 2. So once we've solved this equation, we've determined the value of t when the candle is 12 inches long. And so we can say that when the candle is 12 inches long, 2 hours have elapsed since it was lit. Now, if we know a value of the output of a function and we want to know the input value or values that could have produced this output, we generally have to solve an equation. So if we know an output value and we want to determine an input value, we generally have to do some solving. We often think of evaluating and solving in terms of formulas and equations, but we can actually use graphs and tables to answer most of the same questions. I have the graph of the function f shown, as well as a table of values showing some pairs of t and f of t. If we want to evaluate f at t equals 6, we can use the graph to do this. So if we zoom in on the graph a little bit, we know that we're looking at t equals 6. We look up to the graph, and we look at the corresponding value of f of t. We see that f of 6 is equal to 6. Now, we could have also used the table to do the same thing. So if t is equal to 6, we see that f of t is equal to 6. So using the graph and the table, we can actually evaluate the function f at t equals 6. However, suppose we want to know when f of t is equal to 11.335, or we want to solve this equation for t. If we look at the table, we see that 11.335 is not in our column for f of t, so the table doesn't really help us much. We can't use the table to answer this question. However, we can use the graph to get a decent answer. So if f of t is equal to 11.335, that'll be somewhere around here. If we look at the corresponding value of t, it's a little less than 3. So maybe t is roughly 2.8. Now, using this graph relies on our ability to visually approximate and do that well. We can do a decent job of this with the graph, but the formula would be the only way to reliably get an exact answer for this question. So we see that the different representations are useful in different scenarios. Since different function representations are frequently used, and we are often interested in determining an output value given an input value, or vice versa, it is important to understand how to use our representations to answer questions that involve evaluating and solving with functions.